Welcome back. This is the video on triangles. So in the previous video, I've already explained circles. So we've done areas of circles, perimeter of circles, sectors, segments, chord, arc. We've done all of those. So for this video, we'll be treating just triangles. It's going to be a short one because triangles is, I think, a little bit complex, just very little. So it's not going to take us time to finish. Alright, so the first basic formula for the area of a triangle is half base times height. That is the formula for the area of a triangle. So the area of a triangle is half base times height. Half base times height. That's the formula. So it's more like a rectangle, you know. So hold on. If you have a rectangle like this, the area of a rectangle is length times width or length times breadth. But if you notice, a triangle is like half of it. So a triangle is half of it. So we're always taking the half of length times width, but we then prefer to call it height and base. So that's basically it. So this is the formula. For the first question, we're asked to find the area of the triangle whose base is 7 cm and perpendicular height is 10 cm. So this will be half times the base is 7 cm, the height is 10 cm. Now 2 here is 1, 2 into 10 is 5. So this will give us 35 centimeters squared. So that's the area of that very triangle. Remember to hit the subscribe button, like this video, and share it across to your friends. This is the second video. The third one will be discussing quadrilaterals, area of squares, rectangles, trapezium, rhombus, kite, all four-sided shapes. So we're basically going to be treating them. So whatever exam you're taking, you can just step into the exam hall and deliver full so I say deliver fully or get full marks. The second one, so the second one says find the area of an equilateral triangle of side 6 cm. Now already I've been able to explain how to find that in the previous video. But for this video, I want to introduce a different formula. If you have a triangle and you are giving sides in that triangle, you are giving sides in that triangle, the area can be gotten using Heron's formula, which is the square root of s bracket s minus a bracket s minus b bracket s minus c, where a, b, and c are the sides. Now, in this case, it's an equilateral triangle. So all the sides are the same. So it means a is equal to 6 cm, b is also equal to 6 cm, then c is also equal to 6 cm, because all the sides are the same. So if you have a triangle for some reason, I didn't put that example here though. If you have a triangle for some reason and the sides are different, this is the formula that you can use to get the area of that triangle. So this is the formula you're going to use. Okay, so what is S? We call S the semi-perimeter. First of all, what is the perimeter of such triangles? So the perimeter of a triangle is the sum of all the sides. So that's A plus B plus C. So that will give us 6 plus 6 plus 6. So that will be 18 centimeter. This is the perimeter of the triangle. So what is S? S is half of the perimeter. Half of the perimeter. So that will be half of 18. So that will be 9 centimeter. So this is what? This is the S. That's the semi-perimeter. So area will then become the square root of S is 9. So this is 9 brackets, 9 minus 6, 9 minus 6, 9 minus 6. Remember, it's like this because all the sides are the same. So if you're solving an equation where all the sides are not the same, you can just put whatever the side is here. But the 9 will be the same. The S value is the same, but A, B, and C can actually change. So this is what we have. So this will be the square root of 9 times 3 times 3 times 3. So this is what we're going to be getting. Now this will be the square root of, I kind of know something, and this is 9. 9 is a perfect square, so I'm going to leave it like that, 9. 3 times 3 again is 9. That's also another perfect square. And then times what? 3. So what will happen here is, I'll say this is the square root of 9 is what? 3 times, what is the square root of this other 9? Is also 3 times, what is the square root of this 3? It's a decimal, so we're going to leave it like that, square root of 3. So 3 times 3 is 9. 9 times root 3 is 9 root 3. So this will be the area of that very triangle. But of course, you can basically use a calculator to find out what this will give to you as a decimal. I just did not do that. Okay, so I said before that there's a way to do this. So here's another way. Here's another way. The other way is to use the formula that says area is half AB sine C. It's half AB sine C. So in this case, this will become half times A and B are the same. So that will be 6 times 6. Sine, the angle is 60 degrees. I would explain more about this formula when we get to this very equation. Or explain more about that formula when we get to this very equation. So 2 here is 1. 2 into 6 is 3. So this will be 3 times 6 times sine 60 as a special angle is root 3 over 2. You can actually press a calculator for that though. You can. So 2 here is 1. 2 into 6 is 3 again. So what we're going to be having is 3 times 3. So that's 9 root 3 centimeters square. So this is also another way to do it. You can use a calculator to get the decimal value, but let's move on. So question 3. So question 3 says in the diagram, EF is 8 centimeters. So this is EF. It's 8 centimeters. FG is X centimeters. Then this is GH and this is whatever. It says if the area of the shaded portion is 40 centimeters square, find the area of triangle EFG. So this triangle here that is not shaded is EFG. That is triangle that is not shaded. But first of all, if you look at this shape, there are actually like 3 triangles in it. There's a very big one. A very big one. So that very big one, I'm going to say triangle. The very big one is triangle EFH. EFH is the full triangle. So triangle EFH is equal to triangle. This shaded triangle is what? The shaded triangle is triangle EGH. That shaded triangle, triangle EGH. Plus, what are the one that is not shaded? That's triangle EFG. Triangle EFG. So this is the area that we're looking for. Good. So let's continue. Now this very triangle here, triangle EFG, take note that, like I said before, when I was explaining in the other video, for area, you can basically say area of this is equal area of this plus area of this. You can do it like that. So the areas of each of this will equal to each other. You can only do this for area, not perimeter. Please, not perimeter. You can only do it for area. So the area of this triangle EFH, what would it be? Let's look at this full shape. We know on a normal day that area is half base times height. So this will become half times, what is the base here? The base is this whole thing because it's the bigger triangle, the biggest triangle. So we're going to do S plus 2. So that's the base. S plus S is 2S. So this is 2S plus 2. That's the base because it's the full length of everything at the base. Then times what's the height? The height is what? 8. So this is the area of this triangle equal to EGH. Now, EGH is what? Is 40. It was given to us as 40. EGH is 40. Take note that, you see this triangle here? You cannot say half base times height for this triangle. Do you know why? The reason is this. We only know that the base here is what? S plus 2. We also know that this is what? 8. But life can be easy for me if I just take what they told me, that this will just give me 40 instead of stressing myself. Yeah, instead of stressing myself. Hold on. Okay, I just thought about something. Anyways, let's continue. So we're told it is 40 plus the triangle EFG. This is the area we're looking for. Triangle EFG. I just thought about something. Anyways, let's continue. All right. So 2 here is 1. 2 into 8 is 4. So this will become 4 brackets 2s plus 2 equal to 40 plus triangle EFG. Hold on. Okay. Now, this expression, I need to find the value of x. Yeah, I need to find the value of x. So let's find the value of x. I'm going to leave this expression like this for now. I'm going to leave this expression like this. I'll come back. I should have done something first before doing that part. So if you look at this triangle here, this triangle EGH, I was saying before that you cannot really go and do half base times height. But if you look at the shape, you can actually do half base times height. So triangle EGH, here is why. It was not visible before. It was not visible before that you can do half base times height for this very triangle. But you can because the base is s plus 2. So we know what the base is. But what is the height? The height is what? 8. Take note that you see this very height you see here. We always use the perpendicular height when finding height of maybe area of shapes, and we always make use of the perpendicular height. The only time we make use of what's it called? A slanted height is when we're talking about cones. And even for cones, we're talking about the curved surface area or the total surface area. So this very guy is 8. So we're going to have half times the base is s plus 2 times the height is 8. So 2 here is 1, 2 into this is 4. But remember that this has been calculated for as 40. So 40 will equal to 4 brackets s plus 2. Now I can divide both sides by 4. So this will then give me 10 equal to 4 we cancel 4. So equal to s plus 2. Now I can take this plus 2 to this other side. This will become 10 minus 2 equal to x. So s is what? 8, because 10 minus 2 is what? 8. Now let's continue. So we're going to put this 8 into this expression. We're going to put this 8 into this expression. So this will be 4 bracket 2 times 8 is 16 plus 2 equal to 40 plus triangle EFG. So this is 4 bracket 16 plus 2 will give us 18 equal to 40 plus triangle EFG. Oh God, I'm just doing the complicated. I don't know why. There's another easy way to do this, please. Oh gosh, there's another easy way to do this. But let me continue with this, so then I'll do the easy way. I just thought about another easy way. Anyways, 4 times 18 is 72. So this is 72 equal 40 plus triangle EFG. Now I can take this 40 to this side. So this is 72 minus 40 equal to triangle EFG. So 72 minus 40 is 32. So this is the area of the shape. That's the area of the shape. But that's still complex, please. From this part to this part is useful. After getting your s equal to 8, because we must get the s equal to 8, come and look at this shape. We're asked to find the area of this triangle, this unshaded one. The s, we have solved for the s as what? 8. So the area of this part that we have not yet shaded is half base times height. So that will be half times the base is 8, the height is also 8. So 2 here is 1, 2 into 8 is 4. So what will be left is 4 times 8, so that's 32. In maths, there are different ways to solve questions. So if I were to be in the exam, I think I would choose to use this one. So after solving for s, just this part, after solving for s, I'll then solve for the area I need, instead of going through this long method. I think this going here and here is actually long. All right. So that's it for that. Let's move on to the next question. Okay, for the next question, question 4. So question 4. A triangle has an area of 15 centimeters squared. You have to find the height of the triangle if the base measures 5 cm. We know that area is half base times height. So this means, you see this half here, this will become, the area in the equation is 15. So this is 15. So we have 15 equal to half times our base is 5 meters, okay, 5 cm. I don't know for the cm though. Then times the height which we are looking for. So this is 15 equal to 5 times h times 1 is 5h over 2. Now I can cross multiply here. So 2 times 5h is 30. Equal 1 times 5h is 5h. So I have to divide both sides by 5. So 6 is equal to what? H. So I've solved for h. Let's go to the next one, question 5. Question 5 says find the area of this triangle. Now, area again is half base times height. So this is half times, the base is 10. The height is 5. Take note, you always make use of this if you're talking about height. Perpendicular height is what you're going to be using. So this will become 2 here is 1, 2 into 10 is 5. So what's left is 5 times 5. So that will be 25 centimeters squared. So that's the area of that triangle. The next one, question 6. Now, for question number 6, the formula we're going to be using is area equal to half AB sine C. Now, this is where it gets interesting. These two sides, take note of the diagram because they might look at this diagram now. You will spot the difference very soon. The angle that you must use, must be an arc, must be the arc connecting the two sides that you're also going to be using. Look at it. You see this AB here? These two sides, the angle in between these two sides must be the angle you use here. So since we are using 5.8 and we are using 6.7, we are going to make sure that the angle we're going to put here must be the angle connecting these two. Or it must be the angle between these two lines, how far apart they are. Their angular measure apart from each other. So this will become half times A 5.8, then 6.7, sine 135 degrees. I kind of think this should be root 2 over 2. But I don't have the strength to wait. So I'm just going to pick up a calculator and then put it. So we're going to have 0.5 times 5.8 times 6.7 times sine 135. Okay, so this will give us 13.74 centimeters squared. So this will be the area of that very triangle. That's what the area is going to be. Okay, so the next one, question 7. Now, question 7, we also need to use the same formula, but there's a problem. This is 7.3, this is 8.9. There should be an angle between these two sides. There should be an angle here. There should be an angle here. But now that angle is not known. But it's not hard. It's not hard because we're given this other two. The angles in a triangle must sum up to what? 180. So if this is already 88, this is already 57. To get this theta, we need to do 180 minus the sum of these two. So okay, so the angle is going to be 180 minus 88 plus 57. So that's 180 minus, is that 145? So this will be 35 degrees. So that is the angle. So area is half base times height. So that's half times the base, okay, we're using AB sine C, so not this. AB sine C. So our A could be 7.3, then B is 8.9, and then sine 35. Because 35 degrees is the value of that angle that is between them. All right, so we're just going to use a calculator for this. So we have 0.5 times 7.3 times 8.9 times sine 35. All right, so this is 18.63 centimeters squared. So that's the area of this very shape. Good. Now, one might be asking, how did we get this very formula? How did we get it? Now, just in case you are curious, let me solve question 8 and I will derive this very formula for us. Question 8, calculate the area of this very shape. Now, for this very shape, if you pay attention to it, is the triangle ABC that we're talking about, because this side is not connected. This side is not, so we're talking about the triangle, please. So we're finding the area of this very triangle. Now, if you notice, it has a base of 10. But what is the height? They helped us here. They put the height right here. Because height is basically how far you are from the ground. It's not bent. You know, it's not shaky. It's not bent. It has to be straight. So the height has been given to us here. It has to be something straight that is perpendicular to the ground. That's what height is. So area is half base times height. So that will be half times 10 cm times 4 cm. So 2 here is 1. 2 into this is 2. So 10 times 2 is 20 centimeters squared. So this will become the area of the triangle. All right. Now, how did we get this very half AB sine C formula? How did we get it? Take note that if we have a triangle, let me give any random triangle. So let's say we have this triangle here. Yep. So let me say we have this triangle here. And then we're given this very side. Let's say we're given this side theta. Let's say we're given this very side theta. And then let me call this A, B, C. So this will become side A. This will become side B. Now, I don't know what the perpendicular height is. Because perpendicular height will become the height from the ground to this very point. So let's connect it for some reason. Let's connect it. Let's connect this part. So this will now become the height. This will now become the height. Now, what do you notice here? You notice that this is at 90 degrees, so we can use SOHCAHTOA. This side is the opposite, while this is the hypotenuse. So from SOHCAHTOA, this will be sine, right? Because sine theta is opposite over hypotenuse. So this will be sine theta. What is the opposite to theta? It is h. What is the hypotenuse? It is b. Now what am I going to do here? I'm going to be saying that I can put this sine theta over what? Over 1. So 1 times h is what? H. Then sine theta times b is what? B sine theta. That's what it's going to be. That's what the height is going to become. Now, we always know that area is always half times base times height. That's the formula for area of a triangle. So this is half times, what is the base? The base is down like on the ground. What is the, how much does it extend on the ground? That's A. What is the height? We found the height as B sine theta. So this will be half AB sine. This very theta you see, where is the theta? It's at C. So that's how we got the formula. Half AB sine C. This is how we got the formula for area of a triangle. Now, using this formula, you can actually find the angle. If for some reason you were not given the angle, but you were given area. So this formula stands. There are questions like that. Questions where you'll be given the area, you'll be given the two sides, and they say find the angle connecting those two sides. We're going to use this very formula. Now, someone might be asking, how about perimeter of a triangle? Perimeter of a triangle, just like I solved in this very equation when I was finding semi-perimeter. Perimeter of a triangle is simply the sum of all its sides. So I think that's an easy one to work out. It's an easy one. Just sum up all the sides of any shape. You're going to get the perimeter of that very shape. So remember to hit the subscribe button, like this video, and share it across to your friends. This will be all for this very video. I'll see you in the next one, where we discuss areas and perimeter of quadrilaterals, rectangles, square, trapeziums, rhombus, kites. We're going to do all of those. It's going to be an interesting one. If you're taking your exams, remember to stay connected to this channel. Hit the subscribe button, tap on the bell so that you'll receive notifications when I post a new video. So that'll be all for today. Bye.